Okay.
Alright, this is the introduction to AC with myDAQ. And the objective is to be able to use the myDAQ to measure RMS voltages for various functions and visually analyze them using the NI-Elvis oscilloscope. And for the first part of this, we're going to have you open up the digital multimeter, the function generator, and the oscilloscope. And you do this by going down to the start menu and typing in NI-Elvis. And then you open up the instrument launcher. And then there will be DMM. You open that up. And there should be scope, which is the oscilloscope, and then the function generator. And then that's pretty much it for part one. We just need to have you open up all these three screens. Part two, you just have to set up your myDAQ with a wire connecting A00 and AI plus, and also a wire connecting A ground and AI minus. And your myDAQ should be set up like this.
Here we're going to set up our NI-Elvis function generator, and we're going to start by creating a 1000 hertz frequency with a sine function, and then once we hit run, and then we can see on our oscilloscope our sine function. And then myDAQ and its corresponding software is now correctly configured to read various functions generated. For the following functions, adjust the time base and voltage division controls on the oscilloscope so your screen closely resembles the corresponding figures. Make sure to adjust the function generator DC offset to raise and lower the average value of each time varying voltage and observe the effects on the oscilloscope screen. You can get that from over here on your oscilloscope using the scale. And then for each of the following functions, calculate the theoretical RMS, and then you can find that RMS value down here and record your findings. Now we're going to measure our 1 kilohertz sine wave with a peak-to-peak amplitude of 5 volts. We have our frequency set up over here on our right, and then on our oscilloscope we have our function generator, and this is the image of our sine wave. And then next we're going to do the 10 kilohertz triangular wave. Alright, and then make sure that you remembered to calculate all the RMS values of your different frequencies or amplitude voltages. And then when you measure the RMS voltage, you can calculate that by taking the initial amplitude or peak-to-peak voltage and divide that by the square root of 2. That will give you your RMS voltage.
For part 5, we want you to design an RC circuit, and this is using the myDAQ breadboard with a 1K ohm resistor and a 0.1 microfarad capacitor. And this is basically how you do this. I'm going to hook up that to A ground. And that's that. And for part A of this experiment, we're going to want you to measure the voltage across the resistor. And so what you want to do there is you want to do AI plus connected into the plus side of the resistor, and AI minus connected to this side here. Struggling a little bit here. There you go. For part 8, you're also going to have to set up the myDAQ to read the voltage across the capacitor. And you do this by connecting the AI plus to the positive and the AI negative to the negative side of the capacitor. For part 8, use a square wave of amplitude 2 volts, peak-to-peak amplitude, as the input voltage into the RC circuit. With the myDAQ set up to read the RMS voltage across the resistor, write down the RMS voltage for each of the following functions and try to get the oscilloscope to look like the corresponding figure. Also, for each function, set up the myDAQ to read the RMS voltage across the capacitor using part 7, and that is basically what we just did there with the myDAQ setting up the voltage across the capacitor. For each function, write down the RMS voltage of both the resistor and capacitor and draw a rough sketch of the oscilloscope for the myDAQ setup to read the voltage across the capacitor. Part A of Part 8, we want you to do a 1 kilohertz square wave of amplitude 2 volts peak to peak. And so basically you got to go in here and you set the function generated to a square wave. You change the amplitude to 2 volts. The hertz is 1000. And then as you can see on the oscilloscope, if we can just and it should look like that. And then you can take your RMS voltage, and then you also have to do this for the voltage across the capacitor as well.
Alright, and then now for part B, we change the frequency to 10,000 hertz. And then we'll hit run. And then we can see our oscilloscope square function. And then we can also adjust the scale and the time base.
Part C, we're going to change that same square wave of amplitude 2 volts peak to peak to 100 hertz. And so here we go. Basically it's going to look like that if you can just mess around with the time division to make sure that you can see that. Part E, we're going to change the frequency to 20 kilohertz. So that's the max that NI-Elvis will let us do. Hit run. As you can see, that's the function that you get, and then you get your RMS value down there.